Frege's aim in Grundgesetze der Arithmetik, or Basic Laws of Arithmetic, is to prove Peano-Dedekind axioms as theorems. Peano-Dedekind axioms are thought to be the basic beliefs behind our mathematical knowledge, as they are axioms. These are: 0 is a natural number, 0 isn't the successor of any natural number, no two natural numbers have the same successor, principle of mathematical induction, which is very important to understand mathematical proofs, and every natural number has a successor. Frege wants to go one step further and wants to reduce these basic beliefs into logic, as he is a logicist, according to which all our mathematical knowledge is based on our logical beliefs, logical knowledge. Since Frege's notation is not easy to read, his two-dimensional notation is not easy to read, I will use Edward Zalta's reformulation of Frege's theorem in Grundgesetze. Let's start with Frege's theory of concepts. Comprehension principle for concepts guarantees the existence of concepts. Once we have a formula here, then it guarantees that this concept G, a relevant concept that satisfies this formula, exists. Same for relations. Once we have a formula that involves in two variables, there is a relevant relation that exists again. And as an example, suppose this is our formula: x is an odd number and x is greater than 5. For this formula, we have a concept, and that concept exists, under which only those numbers that are greater than 5 and odd fall. Same for this relation, we have this formula and relation, and the existential quantifier here. And lambda notation is also important to understand Frege's theory of concepts. We have the concept or the function that we abstracted from this formula with this lambda operator. Right, this formula can be this one, and with this lambda operator we abstract the concept, and we have the argument here, and on the right side we have the formula with this substitution. Concept G, argument, and the formula here. This is the substituted version here. So the second step is Basic Law 5. Basic Law 5 is in a biconditional form. Value range of a function is identical to the value range of another function if and only if, for all x, fx is identical to gx. If f is a concept, extension of a concept f is identical to the extension of the concept g, if and only if, for all x, whatever falls under f falls under g. It involves in laws of extension, since when f is a concept, this is an extension. For all f, for all concepts, and for all objects, x is an element of the extension of f if and only if x is an f. Hume's principle, which you remember, I think you remember this from Grundlagen, the number of f's is identical to the number of g's if and only if there is a one-to-one correspondence between f's and g's. It can be formulated in this way: the number of f's is identical to the number of g's if and only if there is a one-to-one correspondence between f's and g's. In Grundgesetze, Hume's principle is based on Basic Law 5. And this principle is based on comprehension principle for concepts. Predecessor relation are also important. There are some definitions that we will use, that Frege uses in deriving his theorems. predecessor relation is one of them. X precedes Y is defined in this way. There is a concept F, there is an object W, W is an F, and Y is the number of F's. Remember, for this part we need Hume's principle. And X is the number of the objects that fall under this concept. So let's see what objects fall under this concept. Those objects that are F but not W. So X must be Y minus 1 because there is only one object that falls under F but doesn't fall under this concept. This is an example for this definition. Precedes 1, 1 precedes 2 is defined in this way. There is a concept F. Let's say that concept is authors of Principia Mathematica, and there is an object W. That object is Russell. Russell is an author of Principia Mathematica, and 2 is the number of authors of Principia Mathematica, and 1 is the number of objects that fall under the concept that authors of Principia Mathematica and not Russell. Authors of Principia Mathematica except Russell. There is only one object falls under this concept. That is Whitehead. There is ancestral relation. Ancestral relation is a general relation. F is hereditary in the R series. R series can be any series. It might be presidents of a country or kings of a country or father of relation, ancestor of somebody. This hereditary relation is abbreviated in this way. For all X, for all Y, for all these two objects, if X is related to Y in this way, the order is important because R might be father of relation. Suppose X is father of Y, implies that if X has this property, then Y has this property as well. Suppose, again, X is father of Y and X is Homo sapien, then Y is Homo sapien. This is the hereditary relation. Ancestral relation can be taught as this real ancestral relation, like father, grandfather, great-grandfather. X is an ancestor of Y is defined in this way. For all F, for all these properties, concepts, and for all objects, if X is, analogically speaking, if X is father of Z, that any object, if X is father of Z, it implies that Z has this property F, and if we know that F is a hereditary property, then Y also has that property. X is father of Z, and we know that Z is father of somebody else. That somebody else is father of somebody else, and at the end of this chain we have Y. If Z has this property, Z's child will also have that property, and at the end Y, this object Y will also have this property. R plus weak ancestral relation is defined in this way. X is either, again analogically speaking, X is either an ancestor of Y or X is identical to Y. So X can be father of Y, X can be grandfather of Y, great-grandfather of Y, or X can be Y itself. Then we can define natural numbers. X is a natural number if and only if X is a member of the predecessor series beginning with 0. a series beginning with 0, there is this predecessor relation. X is a natural number defined as precedes plus relation 0x. To understand this precedes relation, use this one. But as we said, this is a general one. General R plus relation based on any R. If R is precedes, then R plus is precedes plus. So either with this definition, precedes 0, precedes star 0x, or x is 0. So with all these definitions, now we are able to prove Peano-Dedekind axioms. I will not show derivational steps, but what we need to know is that all these proofs are based on these definitions. 0 is a natural number, can be easily proved. 0 is a natural number defined as precedes plus 0, 0. And we know that 0 is identical to 0. 0 isn't the successor of any natural number. It is not the case that there exists an x, sorry for this, natural number x and x precedes 0. So 0 isn't the successor of any natural number. No two natural numbers have the same successor. For all m, for all n, and for all o, if m precedes o and n precedes o, then m and n must be same. Principle of mathematical induction, which is very important. If 0 has a property f, and if we know that f is hereditary on natural number series, then all natural numbers has this property. This for all n quantifies over natural number. Every natural number has a successor. For all objects, if that object is a natural number, then there is another object that is also a natural number, and this first object precedes the second one. So every natural number has a successor. So that's the end of Grundgesetze. Thanks.